Question 6, we have two cylinders shown A and B. The measurements of the radius and the height have been given in the diagram, but it's also written down here. And we're being asked for the first part to work out the curved surface area of the larger cylinder of A. Formula from the formula sheet, our curved surface area is 2 pi RH. So we have 2 times pi times the radius, which is 0.56. Times the height, which is 1.6. Should also mention at this moment the answer needs to be in meters squared, and our measurements here that we're using in our formula are both meters, so there's no conversions that need to be done there. And then the calculator is going to do the hard work. So once we have typed that in, we're going to write down a lot of the number that we see before rounding it. So I type that in, I'm going to end up with 5.62973, so on and so forth. But then the last thing we have to do is round that correct to 3 significant figures. So we have our first, second, third significant figures like so, which means the rounding is going to happen here. And that 9 is going to make that 2 turn into a 3 with the rest of the number before it remaining unchanged. So 5.63 meters squared is the curved surface area. There's no need to find the area of the top and bottom circles here because of the fact that it states curved there. So we are done for part A. Part B, cylinder B is mathematically similar to cylinder A. As soon as we have that statement there, we have our formula involving the length and area and volumes of our two shapes being linked by the scale factor squared and the scale factor cubed respectively. I'm only going to list those two because the question itself is only interested in lengths, and we have area involved here, so there's the potential that that's going to be used later down the road. So we have the fact that 5.63 is the area of the large one, so I'm just going to highlight that right now. This here is our area, our curved surface area of the bigger cylinder. In terms of the lengths of the small and the length of the big cylinders here, we pick any two lengths that are corresponding to one another. So if we look back at our diagram, we have the heights of both of those cylinders. So those lengths correspond to one another. Actually, I'll keep them blue. So that means that 1.6 and 0.6 are going to be the length that we're using for the big. Was that 1.6? Yep. And 0.6 is going to be the length that we use for the small. We have our area of the big, which is 5.63. And although the question itself here is not asking us for the area, we could technically use this formula eventually for the area, although I'm actually making this a lot more difficult than it needs to be, because here, well, we've got options, let's put it that way. Here is our radius, which is a small length, and we have a length here that is big. So actually, we don't need to use this formula at all. We can just use this formula twice, where we're using 0.6 and 1.6 to find our scale factor first of all, and then we're going to use 0.56 and our scale factor to find this length here. So that's the easier way, meaning that's what I'm going to go with just now. So we're using that formula with the blue measurement so far. 0.6 times k is 1.6. That's going to give us a k value of, I should really not be, I always recommend use a calculator, so it's better to be safe than sorry, 1/3. So that's our scale factor. You could use SF instead of K if you feel more comfortable with that. So that means that our small radius, which the question is asking us for, so our length of the small, which in this case is our radius, multiplied by this scale factor, will give us the length of the big, which in this case the radius of the larger shape is 0.56 here. So if I just put it, would be the length of the big, which is 0.56. And in order to get r by itself here, we are going to, there's a few ways you can look at this, but the simplest one would be we're going to multiply 0.6 by 3 and divide it by 8. Or you could say you're going to divide both sides by 8/3. Either way, whichever you choose, as long as you get the correct answer, it will be fine. And in this case, our radius is going to end up being 0.21 meters. Done.